Welcome dear students, welcome for Wisdom 24 channel. In this session we are going to discuss part 3 of trigonometry basics. Okay, in part 3 we are going to discuss trigonometric identities. We all cross the trigonometric ratios, trigonometric complementary angles, everything, and that last part is trigonometric identities, basics I am saying. So let me consider this right angle triangle A, B, C. B which will be the right angle, that is 90 degree. A and C are the complementary angles. These two are complementary angles that I told you in the last class itself, and we proved that also. Now, you know, only for right angle triangle we can apply the Pythagoras theorem. Yes, Pythagoras theorem says that the square of hypotenuse side is equal to sum of the square of the remaining side. So AC square, hypotenuse side square is equal to AB square plus BC square. This is a according to Pythagoras theorem, we got this equation. Now our full work is based on this equation only. Concentrate here. We have to divide each and every term with the particular values. Once we have to divide by AC, then AB, then BC, the whole equation. Now divide equation 1 by AC. By this angle, only for this term AC, you divide by AC for the whole equation. So AB by AC the whole square plus BC by AC the whole square plus AC by AC the whole square. You observe in this diagram AB by AC. See here, this is AB by AC, that is opposite side by hypotenuse. AB by AC. Yeah, from angle A if you are saying means, we can say that from angle A if you are saying means, we can say that adjacent side by hypotenuse. Adjacent by hypotenuse we know that is cos. Cos A the whole square plus. In the same term A, angle A, opposite side by hypotenuse, BC by AC, that is opposite side by hypotenuse is sin A. So we can write AB by AC as a cos A square, BC by AC is a sin A, so the square sin square, so cos A square plus sin A square, AC by AC is 1, so 1 square is nothing but 1. So in this way we got the first identity, cos A square plus sin A square, or cos square A plus sin square A is equal to 1. Actually, this is the first identity. We are using so many complicated trigonometric sums to solve very easily. This identity we are using mostly when we get the cos square and sin square combinedly. We will put in that place, we will put 1 and we will solve to the next steps. Yes. Now, divide equation 1 by AB square. Say AB by AB, BC by AB, AC by AB. So, AB by AB is 1. BC by AB in terms of A. BC by AB, that means opposite side by adjacent, right? Opposite side by adjacent. Opposite side by adjacent is nothing but tan. We know the basic term. Tan A tan square A is equal to, in terms of A, AC, this is hypotenuse. Hypotenuse side by AB. Hypotenuse by adjacent. Adjacent by hypotenuse is cos. So hypotenuse by adjacent we know that is nothing but secant. So secant square A. Thus we got 1 plus tan square A is equal to secant square A. This is the second identity. Whenever we are getting a complicated sums in terms of tan and secant, we can substitute this identity. If it is similar, we can substitute and we can simplify the equation. Next, the third identity we can get from the Pythagoras theorem by dividing the whole equation by BC. So AB by BC the whole square, BC by BC the whole square plus AC by BC the whole square. AB by BC in terms of A, AB by BC, that means adjacent side by opposite side, that is nothing but cot. So cot square A plus BC by BC 1, so 1 square is 1. AC by BC, AC by BC, that means hypotenuse by opposite. Opposite by hypotenuse we know it is sine, so hypotenuse by opposite reverse of that. So for sine there is a procul is cosecant, so cosecant square A. So this is the third identity. Whenever we are getting the complicated problem in terms of cot and cosecant, we can substitute this identity and we can simplify to the next step. So these are all the basic identities how we derive from the right angle triangle. So cos square A plus sin square A is equal to 1 as your first identity. 1 plus tan square A is equal to secant square A. That is your second identity. Cot square A plus 1 is equal to cosecant square A. This is our third identity. So in this triangle, we can evolve these identities only with the help of Pythagoras Theorem. So in this way, trigonometric identities evolved from the basic right angle triangle. These identities we can use to simplify the complicated problems in trigonometry problems. Thank you, students. Subscribe Wisdom 24 channel to get regular updates. Thank you.